All right, welcome back. Let's talk about natural gas, the third of the more common fossil fuels. I'm going to click here. There we go. So natural gas exists as a component of petroleum in the ground as well as in just regular gaseous deposits separate from petroleum. So it could be on its own, but oftentimes we can also find it with petroleum, with oil. Natural gas contains about 80 to 95% methane, which is CH4, and about 5 to 20% ethane, propane, and butane. So natural gas contains a number of different gases, most commonly methane. When you burn natural gas, you can actually see different colors. The different colors are different gases. The different gases have different chemistry, so they burn different colors. The blue flame is methane, the light purple ethane, propane, darker purple butane, and then kind of all the other stuff. So butane, so that's most often what's in like a cigarette lighter. Don't smoke, smokers are jokers. That's butane, so that's flames is kind of orange. If you have a propane grill, that's why, like if you have a can of propane for your outdoor grill, it's kind of a purple flame. So different chemicals will burn different colors. So, but all of those can be found in natural gas. But again, in natural gas, the biggest component is methane. Almost all methane. It's the cleanest burning fossil fuel. It's not clean, but it's of the fossil fuels, it's the cleanest. It's cleaner to burn than coal. It's cleaner to burn than oil, which is great. So when we burn natural gas, it's the cleanest. It releases the least amount of pollution, the least amount of carbon into the atmosphere when we burn it. That's an important distinction to make. Formed very similarly to oil, again, because it forms in conjunction, but sometimes on its own. Microscopic plant material and or biologic life in the ocean 300 plus million years ago died, settled to the bottom, built up layers, built up underneath layers. That organic material condensed under heat and pressure to return to, in this case, natural gas. CH4 is the chemical formula for methane, which again, that's the majority of what natural gas is, with some of that other stuff. So who has the natural gas? Well, by far the number one ranked, at least as of 2018, which is the most current statistic that I could find. Russia, number one. But Iran, Qatar, Saudi Arabia, you can see some of these countries that have high oil reserves. Again, sometimes natural gas comes in oil reserve as well. So that's why some of these Middle Eastern countries are there as well, Venezuela included. United States, fourth on that list. Before we proceed, let me give you another part of the super secret code. It is the number one. The number one. You got me? The number one. So as far as the U.S. is concerned, these are the top 100 U.S. natural gas fields by reserves. Some large ones over here, where there's a lot of coal. Some large ones over here, where there's a lot of oil. Some large ones over here, again, where there's some coal. Large ones over here, and up in Alaska, where there's oil. Some natural gas out in the Gulf of Mexico, where there's also oil. So they kind of go hand in hand. They don't have to. They can be on their own, but they can also be found coal deposits and or oil, petroleum deposits. So, natural gas. Advantages. It contains few impurities and it emits almost no sulfur dioxide or particulates when burned. So when you burn it, again, it's the cleaner of the fossil fuels. Cleaner burning of the fossil fuels. It emits only 60% as much carbon dioxide as coal, which is great. All right, so that's much less carbon dioxide than coal, but it still releases carbon dioxide, just less of it when burnt. And I keep saying this because if just natural gas escapes into the atmosphere on its own, let's say we're drilling it out and there's a leak and the natural gas, which is mostly methane, just leaks out before it's used and burned. Methane that escapes into the atmosphere is one of the most, if it is the most potent greenhouse gas. It is so much worse than carbon dioxide in causing global warming. A greenhouse gas is one that turns the atmosphere into that of a greenhouse. If you've ever been into a greenhouse in the middle of the winter, it's very warm in there. Greenhouses in general, they trap, as the sunlight enters through the glass, it traps all that heat in there. So it could be, you could have a greenhouse in the middle of some place that's cold and snowy, but inside the greenhouse it's relatively warm because the sunlight comes in and the heat gets trapped in there. Well, our atmosphere functions the same purpose. It's good to a certain point, but when we're putting more greenhouse gas into the atmosphere, as the sunlight comes through our atmosphere and hits the earth, we're trapping more heat. So the more greenhouse gas we put in there, the more hotter the earth is going to get. Methane is the worst greenhouse gas. It traps the most heat. So when it's burned, it's better than the other fossil fuels, but when it gets out on its own, it's the worst. When exploring and mining for natural gas, you can contaminate groundwater, as well as cause earthquakes. Ooh, fun stuff there. More on that in a later section. As far as the mining out of natural gas, it's a smaller footprint. You're not ripping up large areas. You have a relatively small area, maybe about the size of, this looks like about maybe a football field, and drilling down to extract natural gas. You do have to utilize a lot of water, and there is some waste involved, but it's usually a kind of a smaller footprint. So again, well, what do you do with the natural gas? You have to refine it to get all the different natural gases kind of separated out, somewhat similar to oil, but we're separating those out to get those different methane, butane, etc., propane, etc. So again, with natural gas, we've made a big switch to that as a fossil fuel we burn to generate electricity. Why? We're tending to find a lot more of it in the United States. It's kind of cheaper to mine out. Again, you can see there's not much that goes into it other than drilling down and sucking it out. More on that in a little bit. There are some environmental hazards associated with it, but it's a smaller footprint, less energy intensive. It burns cleaner. It's plentiful, so it's cheaper. So oftentimes now, all those coal-fired power plants that got taken offline, they were replaced or some converted to natural gas-fired electricity generating stations. So instead of burning coal to generate electricity, we burn natural gas to generate electricity. So that's kind of what's been going on the past 5 to 10 years. It's still putting carbon dioxide into the atmosphere, just less than coal or oil. So it is cleaner, but it's not clean by any means. Again, if this escapes into the atmosphere, there's a leak in a pipe or something, it's very potent. It's the worst kind of gas we can put into the atmosphere to enhance the greenhouse effect, which is what's driving climate change and global warming. So all of these, natural gas, oil, and coal, all these fossil fuels, they kind of all form the same way. In essence, organic material settling down typically to the bottom of water somewhere, whether that's in a swamp or in the ocean, layers built up onto it. So all that organic material gets compressed, a little bit of heat, a little pressure alters it a little bit to create a fossil fuel, whether it's coal, oil, or natural gas. So when we come back, so we'll pause there. So that's the third of the fossil fuels. When we come back, we'll talk about how do we extract this stuff out of the ground. I touched on it just a little bit. We'll get into the specifics of mining this material out, coal, oil, natural gas. How do we get out of the ground? So again, still focusing on fossil fuels. We'll talk about non-fossil fuels, renewable resources a little bit later. Let's just stick to talking about fossil fuels. I'll see you back here in just a second.